Hello guys, in this video we will be solving this question, surrounded regions. This is also a very interesting question because this requires you to tweak the DFS algorithm a bit and sort of a constructive algorithm that you have to make. And what this question is, we are given with a matrix and the matrix consists of only x and zeros. We have to capture all the regions that are four directionally surrounded by x. That is a region, island, right? Island is surrounded by water around it. So we'll have to capture all such islands. We'll not have to capture an island that is at one end exposed to some volcanic lava, let's say. So we have to only consider the islands that is surrounded by water. We do not have to, for example, if we take this as an example, we can capture this three zeros that is in ultra L shape, right? So why not this? Because this is not, this is, let's say, surrounded by lava at one side, right? This is getting exposed to lava in this particular side, whereas this is safe within the water, right? So this is safe, this being safe, we have to consider only these particular zeros, O's. And similarly, we do not have any other case. So that is what we have to do. A region is captured by flipping all zeros into x, and that's around. So we capture this by flipping all these zeros to x. So what is the approach that I get in this question is we have to boundary. There is a concept of boundary traversal of DFS, wherein we just apply DFS to all the boundary zeros or O's, right? So how will that logic work here? See, we have to ignore any cases, like let's say had this zero been in touch with this particular, had this x been zero, right? Had this x been 0 and had this been attached to this, this would of course be attached to this, we would have got 0 0 0 0. We wouldn't have got this as the island. Why? Because this is, we do not have to check 8 conditional, 8 directional, we have to just check 4 directional, right? So this is attached to this particular 0. Had this been 0, we would have got 0 and 0, and since this 0 is attached to 0, this, all these zeros are getting exposed to volcano. I'm calling this as volcano. This is, getting out of bound basically. So we have to ignore that case. Why? Because this is exposing to volcano. So why do we not ignore this case? Because this is not 8 directional, this is 2 directional. Had this been O, we wouldn't have got any island here. Had this been O, we wouldn't have captured any of these O's, because these are all connected to each other and this is getting exposed via this O to the volcano outside. I hope you're getting the perspective. So only 4 direction is what we have to consider, and we have to ignore all such cases. So what we'll do is, we'll start with this particular O, right? And we will, let's say, start with this particular x, and we'll travel this boundary, we'll travel this boundary. As soon as we encounter this O, we'll try to do a DFS traversal for this in the 4 directions. So if we have any number of O's that is attached to this, and it is because of this O that those O's are getting exposed, right? So we'll mark all those as T's. Because all such O's won't be converted to, won't be there in our answer. We'll ignore all such O's. So we'll convert that to T or any other letter, let's say. And if that is not the case, after converting all these O's to T, let's say we would have converted this, right? We would again traverse through this matrix and convert the remaining O's to X. This way we'll capture. We would have converted this to T. Let's say for any letter for that matter, we'll be, let's say, converting this to T, then we'll be having how many O's? We'll be having only this O remaining. So we'll capture this X, 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 and we'll convert this T back to O, so that we do not capture this and we capture only the internal. You see the beauty of the question. This is very great as a question. I love this question to be honest. And let us start coding it. After seeing the code, you would probably get a much better understanding of what this is. Let n is equal to board.size, and n is taking n as the number of rows and m as the number of columns. Equal to 0. Okay, yeah. Now what? Now we'll have to boundary trap. We cannot normally do the DFS traversal like this. We'll have to use the boundary traversal method. And that, since I is the number of rows goes from 0, 1, 2, 3. We'll have to put the number of columns as constant. We'll have to put columns as constant. So if board of I is variable, column is what? Column is 0. We're keeping column as constant, is equal to 0. We're just looking for this particular column at this point in time, right? This x. If this is 0, let's say, since it is char, it is O, right? So if this is O, capital O, right? Yeah, capital O, then we'll have to call DFS traversal, passing 0 as j, and passing board. Fine. And if this is not the case, we'll check. Now, if we are varying the rows, the only 2 columns that can be constant is this first and the last one. So we'll check for this last column now. So if board of I is varying and column is constant, what is the last column now? Is it n? No, n is the number of rows. We have m as the number of columns, right? So m minus 1. If I m minus 1 is equal to O, do a DFS traversal again. DFS traversal of I m minus 1 and board. Having done that, we have covered this case, this particular column and this particular column. Now we'll have to cover this case, this row and this row. Don't mind, like, if we are covering this twice, right? These two edges twice, right? In the first traversal itself, we'll convert this back to, either we'll capture this or we'll convert this to 2. So next time we will not encounter this x or this x for that matter. So now we'll take into account this particular rows. In this particular row, what is constant? Number of rows is constant. Number of rows, the row number is constant. The row number here is 0 and the row number here is n minus 1. What is varying is j. So we'll run a loop for int j is equal to 0, j is less than m, j plus plus. Right? What is constant? If board of row is constant, row in the first case is 0, and column is varying. 0 comma a is equal to 0. You do the DFS traversal for me. DFS of 0 comma j comma board. And the second case, if board, this time board is what? N minus 1. N is the number of rows, so this will be n minus 1. So if n minus 1 and j is equal to this will consider this last row. Will mark DFS of n minus 1 comma 0 comma board. Fine. So this is how we traverse the entire boundary. We have traversed this first, then this secondly, then we have done this first row, then the last row. Now we would be encountering only this O, right? So we'll have to do DFS traversal on that. We'll do that first. Private void DFS int I int j vector okay, board and n is equal to board. We'll write the base case. Base case of what? If it is getting out of bound, j is less than 0, or if it is not, or if board of ij is not equal to O. If it is not equal to O, that is of no use to us, right? In these cases, we'll return. If it is O, what we'll do? We have to mark this as T, or any other letter for that matter. We'll mark this as T in order to store that these O's are not of our use. I mean, these O's are not of our use, so we won't use this. We will not recapture it. We will not capture this. Okay, so we'll take mark this O as T. We do not capture this. If and do not capture all the other O's that are connected to this. In this case, there is no other O's, right? So in this case, only this O will be marked T. Had there been other O's, had this been O, we would have marked all these O's as T, right? So we would not be able to capture any other thing. So we'll mark this, but we cannot capture this. Now we'll have to do 4-way DFS traversal. I plus 1 j and board j plus 1 j minus 1 j minus 1. So having done that, now after this all these steps, you have marked this as T. Now you have successfully made a scenario in which you have this particular matrix in which all these are X, these 3 are O's. Now you have this T. In this case, I mean, in any other case, you would have marked all the unsafe, I mean, all the O's that is touched to any boundary O and that is exposed. Basically, we can ignore that because we have marked that as T. So now we'll retraverse this simply. I is equal to 0, I is less than n, I plus plus. J is equal to 0, j is less than n, j plus plus. Now we'll mark all the O's that are remaining. Those are safe. Those are the O's that we can capture. So we'll mark all the remaining O's as if is equal to O. If it is still O, means it is safe. And if it is safe, we'll capture this. We'll simply capture this by changing this to X. And in case it is T, then it is not safe for us. We'll have to mark that back as O. We'll mark that back as O, ignoring all such unsafe exposed O's. We'll mark this back as O. And do we have to return this? No, we do not have to return this. We have done all the changes in the matrix, and I guess that is what this requires a bit of your constructive thoughts. I mean, how do you approach this one by one? I've missed on something, I guess. I'll pass this. We've marked this as T. So j minus 1 board is not equal to O. Where did I miss? What did I miss? Did I mark this? Okay, board of ij. Let me see what the mistake. Yep, we just had these two minor errors. We just have to check. We are not initializing this, we are checking this. This was one error, and this is another error. We do not have to pass 0 here, we have to pass j. I said j, but I guess I passed 0. Because j is something that is varying, right? So we'll have to pass j and not 0. And this is something that is hard coded. The number of row. This is 0th row and this is n minus 1th row. But j, I mean, for 0th row column will vary, right? We code this way. So that is how I guess this will work. This was very few minor errors. Concept wise, it was exactly what I said. Let me submit this and see. Yep, it is submitted. I hope you would have understood the approach. This was very good question. I mean, first time I saw this question, it was sort of confusing, but then when I did this, it was very, I mean, nice. I mean, the feel you get right after solving a question, that is the feeling I got after solving this one. So that was all for this question. I hope you would have understood the approach, and that was all for this video, guys. We'll see you in the next one. Thank you.